Welcome to the explainer. If you've ever had that brilliant idea at the bedside and thought, hey, this could be a research project, but then felt a little stuck, well, you are in exactly the right place. Today, we're diving into some absolute gems of wisdom for doing just that.
Everything we're talking about today is based on the 100 Research Pearls for Clinician Scientists by the incredible Professor Rakesh Garg from the All India Institute of Medical Sciences in New Delhi. It is an absolute goldmine of practical advice. So, you ready? Let's jump right in.
So, we're going to follow the entire research journey. We'll start with crafting that perfect question, then we'll get into navigating bias, making sure our data is top-notch, look at some principles of analysis, and finally, wrap it all up with interpretation and reporting.
Okay, first things first, and I mean this, every single research study, I don't care how big or small, it literally lives or dies by the quality of its question. If your question is foggy, believe me, everything else that follows is going to be a mess.
And this slide just nails that point. Look at the left. Does sedation affect ICU outcomes? I mean, where do you even begin with that? It's so vague. But look at the one on the right. It's sharp, it's focused. You know exactly who you're studying, what you're comparing, and what you're measuring. That gives you a clear roadmap for the whole project.
So how do you get there? Well, here's a fantastic pearl. Use the PICO framework. That's population, exposure, comparator, and outcome. Seriously, breaking your idea down into these 4 pieces forces you to be specific. It's kind of like a recipe. You need all the ingredients before you can start cooking.
And once that question is crystal clear, you got to pick the right tool for the job. Are you planning to follow a group of people forward through time? That's a cohort study. Or maybe you're looking backward from a specific outcome. Well, then you want a case control study. The point is, the design has to perfectly match the question you're asking.
All right, so you've got your question, you've got your design, you're feeling good. But now you have to navigate the minefield of bias. This is that invisible force that can totally wreck even the best laid plans.
And confounding. Confounding is probably the biggest monster hiding in that minefield. It's this third factor, just lurking in the shadows, that messes everything up. It creates a fake link between two things. For example, sicker patients might be given a certain drug, and of course, sicker patients have worse outcomes. So, was it the drug, or was it just how sick they were to begin with? That's confounding in a nutshell.
And then there's selection bias. Think of it like this. Who you let into your study matters a lot. If you're studying post-operative outcomes, but you only include the easy, planned elective surgeries, your results might look fantastic. But they're not going to mean much for the real, messy world of emergency cases. Your study group has to reflect reality.
This quote just says it all, doesn't it? It perfectly explains something called confounding by indication. That's when a treatment is given because a patient is really, really sick. So when a bad outcome happens, you can't just point the finger at the drug without taking into account the severe illness that made you use it in the first place. Okay, so we're trying our best to sidestep all those biases. Now we get to the actual data collection. And you've heard it a million times, but it's true. Garbage in, garbage out. The credibility of your entire study rests on the quality of the data you collect.
So how do we make sure our data is squeaky clean? Well, here are 3 golden rules. First, don't reinvent the wheel. Use validated tools that everyone already knows and trusts, like the RASS scale for sedation. Second, create a data dictionary. This basically makes sure everyone on the team is speaking the same language and measuring things the exact same way. And third, do a dress rehearsal. Pilot test your forms on just a few patients first. You'll be amazed at the problems you catch before you go big.
We've got our clean, high-quality data. Now for the fun part. This is where the magic happens. Statistical analysis. This is how we take all those numbers, find the real story, and, really importantly, adjust for all those biases we were just talking about. And there's a natural flow to it. You don't just jump into the deep end. First, you start simple. Describe your patients. Who are they? Then you check to see if your comparison groups started out on a level playing field. Were they the same age? Did they have similar health problems? Finally, once you know what the differences are, you can use powerful tools like multivariable regression to statistically account for them. And for a really clever way to level that playing field, you can use something called propensity scores. Now, it sounds fancy, but the idea is actually pretty brilliant. It's a statistical trick to find pairs of patients, one from each group, who look almost identical on paper. It helps make the comparison so much fairer, it's almost like you randomize them from the get-go.
So you've done the analysis. You've got a result. Phew, the finish line is in sight. But hold on, because this next step, figuring out what it all means and then telling the world about it, this might just be the most critical part of the whole journey.
If you take away just one thing today, please let it be this. This is the mantra of all research. Association does not mean causation. Just because two things happen together, like ice cream sales going up when drownings go up, doesn't mean one caused the other. The real culprit? Hot weather. Observational studies are amazing for finding these links, these associations, but they can't prove that one thing caused another. And being a great researcher means being humble and transparent. You have to ask, how do my findings fit into the bigger picture? What were the weaknesses of my own study? Talking about your limitations isn't a sign of failure. It's a sign of scientific integrity. And using reporting guidelines like Strobe just makes sure you're telling the whole story, warts and all.
And that's really the beautiful role of this kind of research. It's a snapshot of the real world. It finds those interesting signals, those potential links, and it basically hands a ready-made hypothesis to the researchers who are going to run the big, definitive clinical trials. It's not the final answer, but it's often the spark that starts the fire.
And where does all this incredible practical wisdom come from? It all comes from the deep, real-world experience of Professor Rakesh Garg. Just look at his credentials. He is a true leader in the field, based at the world-renowned All India Institute of Medical Sciences. So if you want to keep learning, we absolutely encourage you to follow Professor Garg's work. And that brings us to the end. So now I want to ask you, thinking about your own projects, what's the one research pearl you're going to put into practice right away? Thanks for watching.